Hey guys, this is the lesson for using the distributive property to write equivalent expressions. We also will be doing a little bit of factoring to make sure that our expressions are the same. Okay, we're going to start here with number 1. I've highlighted some important information as I read. The Romano family pays for a streaming movie service that costs $8 per month. So we already know they have that. They want to add a second movie service for $D per month. They're not sure how much it costs. Write 2 expressions for the total cost of both services for 3 months. One expression should be a sum of 2 terms, and one should be a product of 2 factors. So we've highlighted the things that we already know about this family, what they're paying and what they want to pay. So we know they're already paying $8 per month, right? So I know that they're paying $8 per month, and they're looking to add another streaming service for $D, right? We already know that they want to add this thing. And then they tell us how much it will cost for 3 months. Okay, so what I can do, so this one that I wrote right here, this expression is a product of 2 factors. It's a product of 2 factors because I know they're already paying $8 a month, plus they want to do extra, like an extra service for who knows how much money. And then we know that they're going to pay it for 3 months. If I were to multiply these, if I was to distribute this with multiplication, I would have an equivalent expression. So we just started off by writing a simple expression with what we already know. So I'm going to go ahead and that's the one we did as a product of 2 factors. Now we're going to do a sum of 2 terms. Okay, what we're actually going to do here is we are going to use distribution to multiply these and get an equivalent expression. So I'm going to multiply here and here. So 3 times 8 I know is 24, plus 3 times D would be 3D. So now I've written a sum of 2 terms. If you can see, here's my sum and 2 terms. So these are equivalent expressions because we know they're equivalent because we know they're already paying $8 per month. If I do 8 plus 8 plus 8, or 8 times 3, we'll get 24. And then 3 months times the cost of the new streaming service, which we don't quite know yet. Okay, so these guys are equivalent expressions. You can also use Algebra Tiles to help you understand this. So we know that for the first month, they're paying $8, second month, third month, right? We know that each one of these squares represents $1, and then we're going to add it with 3D. We know they're going to be paying for 3 months, but we're not quite sure of the individual cost. Okay, so that shows us both expressions where we have 3 times 8 plus D. And then it also shows us that if we were to count all these together, we would have 24 plus 3D. Okay, so algebra tiles are a lovely way to look at both expressions. Okay, and then we use the distributive property to make them equivalent. All right, number 2, we're going to use the distributive property to rewrite 5x plus 3 times 2 as a sum of 2 terms. We're going to show our work. Okay, so I'm going to start off by writing the problem here. Now, sometimes, well, most often, your number will be on the front here, but either way, it's fine. We have the commutative property, which means it can go back or forth either way, and it'll still be the same thing. Okay, so what we're going to do here is we're going to apply this 2 with multiplication. We're going to distribute it to both of these terms. Okay, so I'm going to do 2 times 5x would be 10x, and then 2 times 3 would be 6. So an equivalent expression, or a sum of 2 terms, would be 10x plus 6. Okay, we can use the commutative and associative properties of multiplication to reorder and regroup factors. Explain how you used one or both of these properties in your work. So I could have solved it this way and gotten the same thing. I could have rearranged my 2 and distributed it this way, and I still would have gotten 10x plus 6. That's the commutative property. So I am moving it around in different ways. The associative property would be to separate it a little bit more. So I can show you. I would do 2 times 5x plus 3 times 2. And we would still get the same answer. 2 times 5x is 10x plus 6. Either way would work for us. Okay, which expression is equivalent to 63 plus 56? So all of these have different types of numbers sorted out and factored. What I want to do here is look at this main one here. And I'm going to look at these numbers and think, did they have anything in common? I know that 63 and 56 have a greatest common factor of 7. I know that I can multiply 7 by both of those. So automatically I can look on my answer choices down here and see that this one has a greatest common factor of 7 and this one has a greatest common factor of 7 used in some way. These other ones do not. So I'm going to cross these out. We don't want those. Those are not going to help us out. Okay. And looking at our number here now, because I have a factor of 7, that means I can go ahead and factor those out. So what times 7 makes 63? Well, I know 9 does. And then what times 7 makes 56? I know 8 does. Do I see an expression that looks like that? Yep, right here. This one would not work. 7 times 9 would be 63, but 7 times 56 would definitely not make 56. So we also know that this one is incorrect. So A would be our correct response. All right, number 4. A company sells fruit cups in packs of 4. The packs currently weigh 20 ounces. The company plans to reduce the weight of each cup by n ounces. The expression 20 minus 4n represents the new weight in ounces of a pack of fruit cups. Rewrite the expression for a new weight as a product of two factors. So right here, what we're doing is we're actually looking for the greatest common factor between these two numbers, and then we'll factor it out. Okay, so when I'm thinking about, let me get the right marker here, 20 and 4, what is their greatest common factor? Well, this one only has 4 and 1. This one has 2 and 10, 4 and 5, and so forth. When I can see already, the greatest common factor that both of those share is 4. So the way I can rewrite it is by saying 20 minus 4n. I'm going to pull my greatest common factor out. What would I multiply times 4 to get 20? 5, right? Then I'm just going to bring my operator down here. What will I multiply times 4 to get 4? 1, right? And then I have my variable n. In most cases, we don't want to use that 1 because we kind of like assume that there's already a 1 there. So now we have made it a product of two factors. So I have 4 times the quantity of 5 minus n. Yay!